Hello viewers, in today's class we are going to take up one important and conceptual problem from derivatives, right? And here we are given a problem, and the problem goes like this. If a function f of x is given as sine inverse 2 times 3 raised to x divided by 1 plus 9 raised to x, then we have to find the derivative of this function at x is equal to minus 1 over 2, right? So here let us first closely observe this function, right? So here the function is given in the form of inverse sine function, and inside this bracket we have the terms 2 times 3 raised to x over 1 plus 9 raised to x, right? So if we closely observe this function, we arrive at the result that here we have to make a proper substitution, right? So in order to find the derivative, that is f prime of x, so what we will do, we'll try to make out important substitution here, and if we realize or if we remember an important result from trigonometry, which states that sine 2 theta, right, sine 2 theta is equal to 2 tan theta divided by 1 plus tan square theta, right? So here the application of this important result from trigonometry will be used here, right? So what we will do, we'll put t is equal to, right? So or in other words we can say that we can substitute 3 raised to x is equal to tan of t, right? So 3 raised to x is equal to tan t is the proper substitution here in order to reduce this result in this form, right? So let us see how we can reduce this function to this formula, right? So this function f of x now becomes equal to sine inverse, and we have 2 times of tan t, right? So here we have tan t because 3 raised to x is tan t, and 9 raised to x, 9 raised to x can be written as 3 square raised to x, and now we can interchange these two indices. So we have 3 raised to x, and here we have square, right? And 3 raised to x is our tan t, so we have here tan square t, right? So now in the denominator we have 1 plus tan square t, right? So now we can easily see that this result is similar to this one. So now we can write sine inverse, and 2 tan t over 1 plus tan square t can be written as sine of 2 times of t, right? And here by the definition of inverse trigonometric function, this sine inverse and this sine get cancelled. We are left with 2t, right? Provided that we have the principal branch. So now we have f of x is equal to 2t, and from here we can easily find the value of t in terms of x, right? So t is equal to tan inverse of 3 raised to x, right? So we can substitute it here. So f of x now becomes 2 times tan inverse of 3 raised to x, right? So now we have the simplified version of this function, and now we can easily differentiate this function, right? And here we know that the derivative of tan inverse x, right, we have to use this result here. So the derivative of tan raised to x is equal to 1 over 1 plus x square. Moreover, we have to here also apply the result, that is the derivative of a raised to x is a raised to x, and then we have log of a, right? Okay, so now let us differentiate this function with respect to x. So we have f prime of x is equal to the derivative of 2 times tan inverse 3 raised to x, right? So this 2 can be taken out because this is a constant. So we have 2 times derivative of tan inverse 3 raised to x, right? So now we have the derivative of tan inverse x is 1 over 1 plus x square. So first we will take 3 raised to x is equal to x. So we have 1 over 3 raised to x whole square, and then we'll differentiate this function by chain rule, right? So now to differentiate 3 raised to x with respect to x, we'll make use of this result. So now we have 2 times 1 over 1 plus 3 raised to x whole square, and then the derivative of 3 raised to x is 3 raised to x and log of 3, right? Because for a we have 3 here, right? So now we have the derivative of f as this function, and now we have to find f prime of minus half, right? So what we will do, we'll put x is equal to minus half in this result. So we'll have f prime of minus half, and then we have 2 times 1 over 1 plus 3 raised to x. So 3 raised to x can be written as 3 raised to minus half, and here we have the power 2, and then we have 3 raised to minus half and log of 3, right? So now let us simplify it. So we have 2 times 1 over 1 plus 3 raised to, here 2 and 2 get cancelled, so we are left with 3 raised to minus 1, and here 3 raised to minus half can be written as 1 over root 3. This is log of 3, right? So now we can easily simplify it. So this is 1 plus 1 over 3. Here we have 1 over root 3 log of 3, right? So now this can be written as, this is 4 over 3, so this is 2 times 3 over 4, and here we have 1 over root 3 log of 3, right? So we can cancel this 4 by this 2, so we have 3 over 2 times 1 over root 3 log of 3, right? So this can be written as 3 over 2 root 3 log of 3, right? So the value of f prime of minus half is equal to 3 over 2 times square root of 3 times log of 3. Now viewers, here it is very interesting to note that we can also express this result in a slightly different way. See, here we have 1 over 2, right? So if we take 1 over 2 as the power of 3 here, and if we rationalize 3 over square root of 3 by root 3, we'll have 3 over root 3 times root 3 over root 3, and then we can write 3 raised to half, right? So this 1 over half will go to the power of 3 here, so we'll have 3 raised to half, and we can rationalize 3 over root 3 by root 3, right? So this is 3 root 3, and this is root 3 times root 3 is 3, so these two get cancelled, so we are left with root 3 times log of root 3, right? So this value can also be taken as the final answer.